Okay, everyone, finally to our first of our group problem solving questions. Now, if you're alone right now, feel free to imagine that you have someone with you to help you. I would pick Einstein, somebody really good at math, like Sir Isaac Newton, to do this. He invented calculus. Personally, I always imagine I have an ethereal sloth with me at all times. It's always worked so well. Okay, with that in mind, sorry, I got a stupid sense of humor. Let's look at the problem. So we have a train, and it's going at a speed of 20 meters per second and an acceleration of 14 meters per second squared, acting in the direction shown. A direction. Oh no, it's like we're going to break into components. Which isn't that difficult, just a triangle. What we want to figure out is the rate of increase in the train's speed and the radius of curvature of the path. Oh, the radius of curvature thing. It's back. Who'd have guessed? But don't worry, don't have to use that crazy equation yet. I'm not saying you won't ever have to use it, but don't have to use it quite yet. So what's your plan? Well, determine the normal and tangential components of the acceleration. It's a triangle, break it into components. And then calculate everything else from that. So, as always, I'm going to have you pause, go work on it, talk to your imaginary friend and get help, and then come back and see how you did. So 3, 2, 1, and go forward. So first off, we gotta break it into components. This is a triangle. If you're really struggling, redraw that triangle. Okay? And then it's not too hard to figure out what those components are. This is the tangential. This would be the normal. If you want to, you can also draw it like this. Make sure that you have choose the right angle. And so we get the tangential is 14 cosine of 75 because it is adjacent over hypotenuse. And our normal component is sine of 75 because it is opposite over hypotenuse. Okay, so we know what the tangential and normal components are, and we're going to work backwards to figure out what everything else is. Well, the tangential component is simply equal to v dot. It is the rate of increase of the train's speed. So tangential component will be equal to v dot. Normal component, let me erase all this over here, a little bit crazier, is going to be v squared over rho. We know what the velocity is at this particular point. It's 20 meters per second. We just don't know what rho is. However, one equation, one unknown, so we can solve for rho and it comes out to be 29.6 meters. Now, wasn't that incredibly difficult? It's not. These equations are very, very simple. We will have harder problems. These are just the beginning examples. And the homeworks will build up from here. But in the end, if you just don't forget it, if you write out your equations, you will be able to solve this. Because even if you didn't know directly to do this, you could write out your acceleration equation. You could have said, okay, well, A is equal to, how do I do this? Yes, AT in the UT direction plus AN in the UN direction. And then you go back and say, okay, well, what are AT and AN? Well, AT is going to be equal to V dot, okay, that works, plus AN, which is V squared over rho, okay. Got this, and you are going to connect that. So you're like, okay, well, V dot is this. V squared over rho has to be equal to, where's my component? Way over here. There you go. And we have it. So, please do not forget this. If you're really stuck, write out your equations. And if you're getting stuck right at the beginning, remember everything in this class is triangles. It always comes down to triangles. So break things into components. If you can't visualize it, redraw the picture. And if that still doesn't work for you, come and talk to me, digitally. And we'll go from there. So, I hope this helps you. I'll see you all next time as we do our last group problem. Have a wonderful day.